All right, let me go ahead and just get started real fast here. So disclaimer is the code I'm presenting is notional, but it's based on an implementation we have back at LANL on our flag code. The point of this talk, though, is really to spur conversations. The implementation we have is, I'm not even sure it's the right implementation, and the more I think about it, the more I think it isn't, but it's more to spur conversations, to ask questions, maybe to get feedback on how to do this better. I think what we have is better than just using raw unique token and concurrency, but I think there's something even better lurking out there, and maybe we can figure it out together. So everything I'm going to talk about is really based on this example code. So suppose you have this serial for loop, and outside you've allocated some matrix, some vectors, and the key is that in there is only known at runtime, so you can't use like stood arrays or something like that. You really need something that looks like allocating memory inside of a parallel for, which is a big no-no, but I need some sort of memory. And also one of the key things is that I typically need this in kernels that are fairly complex, like that typically are going to use a lot of registers, they may have a lot of branching, like right here, let's say we're populating matrix elements in a vector and then we're doing a solve. That's pretty heavy duty stuff, and then other things might make it expensive. So that's one of the other key details. So yeah, you would say, all right, how do I do this? Slack, they're going to say use a team policy, and I'm going to say I don't know that I want to use a team policy, but the more I think about it, the more I think maybe I want like team policy light. I actually think that might be the best way to implement this. And yeah, you can do this with, so yeah, there's a lot of questions if you go this route. I thought about it. Let's see. Yeah, okay. So you might, like if a developer is just looking for memory inside of a kernel, they may not want to think about what a global or a local scope is. What's a lock table? One of the biggest issues that we have, or that I think we're having, is I think we were hoping to get memory savings out of this, but it turns out in a lot of situations, the concurrency on GPUs is sufficiently large that a lot of our loop iterations are smaller than the concurrency. And so you just end up falling back to allocating enough memory for every loop iteration to get something. The issue is that I suspect the vast majority of our kernels are reaching a very low achieved occupancy. And then if you take that into account, you should be able to get actual memory savings and all of the performance and portability and all of the good stuff. So let me just go ahead and skip to the good part here. So we have something called the planner, and then a parallel for scratch, which is a little bit different than you might implement it if you were implementing it like in Kokkos. But in the plan, you're basically saying the plan has the ability to add. So for the matrix, you're adding a double, and it's of n by n, that the thing can take arbitrary types. Well, not quite arbitrary. I think they need to be trivially copyable, but I think you could relax that to some degree. Anyway, you can take it in a type, it takes in a length, that can be an arbitrary rank thing that maps to a view. That thing knows the size per iteration, basically. That's what it's calculating, and it's doing it in kind of a nice way for developers, some nice syntactic sugar there. And then you take in your range policy, that plan, and then with that, and this other user-defined lambda that then's going to get slurped into a different actual, device lambda kernel that goes into the real parallel for. And what it's doing is it's looking at your range policy. It's looking at, is that smaller or larger than the concurrency, and it's doing some optimizations under the hood. But anyway, I feel like this is clean enough for our developers that they can write it, they can understand it, and it gets them on their way relatively easily. Let's see, so yeah, details, yeah, like I said, it takes arbitrary rank and type things to size. We do what I like to call a small loop optimization, and that's just checking for the size of the range policy versus the concurrency size. And then if it's smaller than it, you don't even need to acquire or release the token, because your thread ID is just the iteration ID. let's see, what else? Yeah, developers don't need to worry about all the complex implementation details under the hood. And then potential pitfalls, no memory savings, like I said. I think, I'm not 100% sure, I think there has to be a kernel that has to be launched to reset the lock table in between usage of the token, or at least some sort of resetting, memset, whatever that is. I don't understand. And then one of the biggest questions, and maybe since we're short on time, maybe we save this for either after my talk is over, which should be fast, or the coffee break to talk about, is there something we can do about this? And maybe the answer is we need to use Kokkos tools to gather the occupancy information, and then you can dial it down during runtime. But yeah, this is something I've already said, that our experience is these kernels tend to be complex. They're not going to hit max occupancy anyway, so the memory savings might be bigger for us than trying to get max occupancy. So if there's some way we can instruct or hint at the runtime to give us a lower occupancy, that would even be helpful. I posed this question on Slack a bit ago, a few months, I don't recall exactly. And it seemed like the state of the art was just to record the occupancy for a given machine, for a given kernel, and then use that as a multiplier on your concurrency, and that's how you get the memory reduction. That feels pretty clunky to me, and then you also have to do the profiling per kernel. That's somewhat expensive. I'm hoping maybe in the after discussions we can come up with a better solution. And then, yeah, this is just comparing. On the left is an implementation I've done in one of Lanel's codes called Singularity EOS. That's an EOS library. This isn't exactly it, but it's based off that. This is how it might look if you did it just using unique tokens. And then on the right is with our new planner and our custom parallel 4. So then what to do? Does this belong in Kokkos core? I don't know. I would be willing to contribute code, but I would also like to see if there's a strong desire in the broad community for something like this. I think the actual implementation would be more like to have either a team policy light or a scratch memory policy or something like that, where it provides you, rather than a team type, it provides you something that contains like the custom view allocator thing that knows its scratch size, and then the global iteration ID, and then the thread ID like thing, which is just the token, and it does the release and the acquire for you. I think something like that might be a good implementation if it were internal to Kokkos. And then the rest of these are just questions that I'm gonna pose for people to think about, and I think we may be just about out of time, and I don't want to take away from your break, so I'll stop there. Thanks.
Thank you, Daniel. Yeah, I mean, we're right on time again, so I think it's just fair that you get a bunch of questions.
So for both you and other people, I mean, we have heard this thing before, right? If you had similar to, or essentially the same as in team policy, set scratch size on range policy, you get a thread handle instead of a team handle, and you pass the thread handle dot scratch into your view. Yep. Would that address all your concerns? And I mean, all the stuff you said about occupancy and whatnot, we do take that into account, for example, in the team policy. So we have that information internally.
As long as I don't have to know when to wrap things in a single versus like a team vector range, I want it to assume that when I'm in there to give me the maximum amount of parallelism, and I don't want to have to think about singles or team vector, team thread.
No, there's no team vector thing. You just get into instead of just getting an index, you get a handle and an index.
Right. Yeah. Yes.
And then you ask
That's right. And if I could pass that into views like in the hierarchical parallelism.
Yeah, exactly.
I think that would be good, yeah. Because it already provides the way to set the scratch memory size.
Yeah, exactly.
So-
That's what I'm asking for,
Yeah.
right? If that is,
Yes.
if that would be,
Yeah, at least for our purposes. I mean, I'd like to profile it, but I think that that would be sufficient, yeah.
okay.
Do you also need something to synchronize to make effective use of this, or would just the memory be fine?
I think the memory would be fine. In most of the cases, it's just we have runtime known memory sizes. So it would be fine to just say, we're going to allocate it at the beginning, at the top of the kernel, and release it at the bottom. And
Okay.
that's really all we need. And I guess my thinking is that that's not an uncommon use case, but I could be wrong. I could be just in my own LANL bubble and not thinking about how other people use it. But
We even Rohit was looking for him was asking for this earlier this week, so you're not alone.
okay.
No further questions. Let's thank Daniel again and all the speakers in the session.